Hello, so in this video we're going to look at a demonstration of how to generate pseudo-random numbers in C. So we're going to start with the first example that you saw in your book. I believe this was in figure 5.11. And what you're doing is you're basically looping through a variable from 1 to 20. It's an unsigned integer variable. You print random numbers between 1 and 6 at each run of the loop. So at every run of this loop you select one number randomly, or rather pseudo-randomly, and then after you have printed 5 randomly selected numbers on your screen, you go to the new line. So simple program. Let's just run this, and you get this output 66556, and you can double check from your lecture notes, but this was the exact same output that you were getting in your lecture slides as well. So if I maybe copy these, let's see if I can copy them. So I copy these for reference, let's just say, and maybe if I run it one more time, let's see what happens. I should get the same numbers. So let me repeat this experiment one more time, and let me compare this with my previous output. So 66555651153. So exactly the same output. So not exactly random. That's why we say these are pseudo random. But we studied how this can be changed, and we will see that in a second. So that's pretty much all I want to say about this example. Well, let's just do one more experiment. So let's try that 15 to 20 example that we were talking about. So let's try to move our numbers from the range of into the range of 5 to 20. See if that works. Right, so no number is less than 5, no number is greater than 20. So yeah, seems to be working. All right. Right, so let's just put this back to its current form, and now let's move on to the next example. Which was this one. What does this say? All right, so now we get to the next example, and in this next example what we're basically doing is rolling a die 60 million times and then counting the frequency of occurrence of the integers 1, 2, 3, 4, 5, 6. One thing I want to point out, the book initially at one point says on the slides it says that this experiment is actually repeated 6 million times, but when it writes the code it actually does it 60 million times. So we're going to do it 60 million times and not 6 million times. And then one more thing, so what you would expect then is that the frequency of occurrence of each one of these numbers, because they are equally likely, or there is an equal chance of them to be observed every time this experiment is run, you would expect the frequency of occurrence to be 10 million instead of 1 million, because now the experiment is being run 60 million times, not 6 million times. So yeah, so what do we have in this? We run our loop, So we roll our die 60 million times. Every time we basically generate a number between 1 and 6. We select it randomly, or at least pseudo randomly, and then we have a switch statement which decides based on the value that it observes. It increases the frequency or the number of observations of whatever number is generated. It increments the value by 1. One more thing which is generally advised or is good practice is whenever you have these values, whenever you have bodies which are of statements which are multi-line and are generally very big in size, what is recommended is that at the end of each body of each statement, you may want to write which one is being ended, because here it's kind of difficult to identify which one is being ended. So if you write down the comment end switch, it tells you that the switch ends here, and this kind of indicates that maybe the for loop ends here. So this is generally good from a reading perspective if you want other people to read your code. Right, another thing that you also is useful, and I'd like to illustrate here, is you might have noticed these bar signs here. So if you actually go here, you see that it kind of highlights the switch statement and everything inside it, and this actually is a minus sign. If you actually click on this, if you left click on this, what it does is that basically it rolls your entire body of the switch statement into one line. It kind of makes it disappear. So click on this and you see that everything inside your switch statement basically now appears to be in a single line. Now it hasn't disappeared, it's just that it has come inside, it's not being displayed. It's still there, it will still run, it's just that it's not being displayed. It's being displayed as one line, and you can use this feature if you say want to you want to read a loop, or you are trying to understand some code that you or somebody else may have written. So that's when this comes in useful. In fact, you can also roll other parts as well. So if you try to click on this, I think it will roll the for statement, and you actually see everything inside the for statement. It's still there, but it's just that you are kind of making it more compact. So it makes it easy for you to understand what the program is doing. Okay, so let's run the program now and see what it does. Right, so this program basically runs 60 million times, so it will take a little bit of time to execute. So notice these numbers. If you have a photographic memory, you probably remember from your lecture slides that these were the exact same numbers that we got, but let me just save them to make sure that we actually can double check them again. So let's run it one more time, and let's compare, and you see that 9999294 is exactly what we get. 102929, 102929, and you can compare the other numbers as well. But yep, we are generating the same numbers again and again 60 million times, but all observations in that 60 million repetitions of this loop will be pseudo random, will be exactly the same numbers in the exact same order if we use the same seed every time we conduct this experiment. If we change the seed, then obviously it will change, and we will see an example of that. So let's look at the next example quickly. So how did we change the seed? Well, we use the srand function to change the seed. So This is our simple die rolling example, and let's see if using different seeds actually changes our output. So let's run this. Let me enter the exact same seed as the book, 61462 16164. This is the exact output that you actually see in your lecture sites as well. You can double check these. Let's repeat one more time. Let's use the 867. You get different numbers, 24616. And if you repeat one more time, and let's say again we use 67, you get 616462166164. So exactly the same output as you got the first time around. So if you want different numbers, if you want the experiment to kind of behave differently every time you run it, then you have to change the seed. If you do not want to do that, then just keep one seed and it will keep reproducing the same type of results. So it just depends on what you want to do. All right, so that's it. Thank you. I will see you in the next video.